Pleasant Chemistry, where we release video weekly. We discuss about chemistry in this channel. So if you are new in this channel, kindly subscribe so that you can get updates on every of our videos that we release weekly. Today we want to consider calculations based on empirical and molecular formula. In our volume 1, we've discussed some calculations. So today we want to continue with the calculations related to empirical and molecular formula. So this is volume 2. Now the question: the mole ratio of carbon to hydrogen of a volatile compound is 1:2 if on evaporation at STP 0.12 gram of the liquid gave 32 cm3 of the water of the vapor. Determine the molecular formula. 1 mole of a gas occupies 22.4 dm3 at STP. Recall, in our volume 1, we discussed that the molar volume of a gas, which means that 1 mole of a gas occupies 22.4 dm3, and that's a standard value. That's a standard value for a gas, 1 mole of a gas. And also, 1 mole of a gas can also represent the molar mass or relative molecular mass of the gas. We have established that in our volume 1. So if you are new in this channel, you can go through the volume 1 so that you have a better understanding of what we are about to do right now. So I said 22.4 dm3 is also equivalent to relative molecular mass, RMM. This relative molecular mass can also mean molar mass. RMM is most of the time used for a single element or the mean mass of an element. So when we talk about molar mass means the addition of the masses in a particular compound. Now, according to the question, the mole ratio of carbon is 1 and the mole ratio of hydrogen is 2. Therefore, we have the empirical formula to be CH2. Now remember, CH2 into bracket N is equal to RMN. That's our equation 1. In that equation 1, CH2 is the empirical formula. It has been given in the question that the mole ratio of carbon is 1 and the mole ratio of hydrogen is 2. So when we enclose it, that N is the number of carbon that we want to calculate. Now that N, when we calculate that N, it will make us to know the molecular formula. So I have the equation 2 now. 22.4 dm3 is equal to RMN. That is 1 mole of a gas. The molar mass of a gas is equivalent to 22.4 dm3. Now that's equation 2. Now because in the question we were given a particular value in centimeter cube, so therefore we are going to convert that 22.4 dm3 to centimeter cube, and 1 decimeter cube is equivalent to 1000. So we multiply 22.4 dm3 by 1000 to give us 22,400 centimeter cube. So if you watch the volume 1, we equate that molar volume to the relative molecular mass and the initial volume that was given in the question to the mass, which is 32 centimeter cube. We equate it to 0.12 gram. So now we want to make RMM the subject of the formula. We are calculating RMM because without RMM we cannot determine the empirical the molecular formula, since we have known the empirical formula. So now we want to calculate relative molecular mass. We cross multiply from the equation in a diagonal way. 0.12 multiplied by 22,400 divided by 32 cm3. Now therefore we have 84 as our RMM. That 84 can also mean our molar mass. So if it is our molar mass, we are going to add the unit to, which is a gram per mole. Now we have gotten our RMM. We can substitute that RMM to equation 1 in order to determine our molecular formula. So when we put that 84 into equation 1, we are going to have CH2N is equal to 84. And remember that the atomic mass of carbon is 12 and the atomic mass of hydrogen is 1. So when we add the atomic masses together, we are going to have 14. Note that we actually want to calculate N. So when we add 12 and 2 together, it's going to give us 14, which is equal to 84. Then we make N the subject of the formula by dividing 84 by 14, and that will give us 6. By the time we divide 84 by 14, it's going to give us 6. And note, this 6 is the actual number of carbon, the number that we were supposed to put at the base. And so we have calculated N now. Okay, therefore the molecular formula is, so we go back to our equation, CH2 into bracket 6, that N is now 6 now. Then we use that 6 to open the bracket. So when we open the bracket, we are going to have 6, then 6 times 2 is 12, CH12. Then we have the IUPAC nomenclature is hexene. If the question is asking further that you should give the IUPAC nomenclature, it is hexene, since the carbon is 12 and the carbon is 6 and the hydrogen is 12. Thanks for watching.